trigonometry has got to do with the properties of the right angle triangle. Already you know right angle triangle because you have done angles. So if you know what the videos on angles, check it and you know why you are going to apply it over here and how it's going to behave. Alright, so to the next stage. This is the right angle triangle. You know one angle, one of the three angles must be equal to 90 degrees. That is the only guarantee that it's a right angle triangle, right? Now, this is the symbol of a right angle. So the examiner can decide to put it here. The moment you see that symbol at that corner, that angle is equal to 90 degrees. Take it. It may not look like one, but the symbol is an identity telling you that that angle is equal to 90 degrees. You get a picture? So take note of that. Very, very important. But for now, it is not. This is the right angle. So you have right angle here, you have right angle there. Let's talk about a fair shape. Now, the moment you identify the right angle, the side direct opposite to the right angle is the hypotenuse. And it's normally the longest part on the three sides. Okay? The side direct opposite is the hypotenuse. Now, the angle in question, or the angle you're using to do the calculation, I'm talking about SOHCAHTOA, that angle, the side direct opposite to that angle is the opposite. So, like the name sounds. So, the angle you're using in your calculation, so if you're writing cos theta, the side of the triangle direct opposite to that theta is your what? Is your opposite. So if I'm using this angle here, this angle x, if I'm using this angle to do my calculation, then what does it mean? This side will become my what? My opposite. So there's no argument as to which side should be hypotenuse. Just indicate or identify the right angle. You are free. Then the angle you are going to use in the calculation, the side direct opposite will tell you the opposite. The remaining third side is automatically the adjacent. No argument. Are you okay? Good. So there's no issue here. So when it comes to this one, it's similar. So you can see that this one, the angle is here. Therefore, this is the opposite. Hypotenuse has no negotiation. Just identify the right angle. The opposite is hypotenuse. And the third one becomes automatically adjacent. Right? So when you're given a question, you go by this and apply. Are you getting it? So let's move on. Now, the SOHCAHTOA I was talking about, which is a song in most of the senior high schools. SOHCAHTOA. If you have not heard it before, I'm telling you this. So you can sing it. It's a very nice song. SOHCAHTOA. So the so is telling you sine. And the full spelling of sine is this. But I write it in short as this. So it's not sin. It's not sin. It's what? Sine. So when you see S-I-N in mathematics, it's sine, not sin. Sine the angle. And for the sake of what I'm doing, the angle, I'm going to represent it by angle by what? Theta. So sine theta must be equal to, O stands for what? The opposite. So equal to the opposite over capital H stands for what? Hypotenuse. So if you identify it and you know the angle, you put them in place and go. Whatever is missing is change of subject, which you are going to see. The next one is Ka. So keep this SOHCAHTOA. Ka is talking about cosine, but the short form is cos. So cos, the angle must be equal to Ka adjacent H hypotenuse. You are free. So always write your SOHCAHTOA down. The one they mentioned. The first letter goes so sine, cosine. Okay. The last but not least, third one is toa. Toa is tangent, which is shortened as tan. So tan the angle. So tan theta is equal to O stands for what? Opposite. A stands for what? Adjacent. So it's the three dimensions you'll be using. Either it is hypotenuse, opposite, adjacent. And that's why we have this acronym for you, shortcut for you to use. SOHCAHTOA. If you need hypotenuse, change your subject. If you need opposite, change your subject. If you need theta, change your subject. And inverse property is what you're going to apply. So as you solve question, you see how to apply them. Simple. So let's go. Okay, so at this stage, the next property, we have talked about SOHCAHTOA and how to write it and apply it. Now, the Pythagorean triple. Pythagorean triple. And the Pythagorean triple is saying that if you draw a square here at the hypotenuse, which is the longest part, so let's assume this is a square, take it. It's supposed to be here because of the space. Forgive me. You draw another square here, square, then square here. So let's assume this is a square. Square of the hypotenuse. So this is h. This is a small letter h. This is b for base. The square of the hypotenuse alone is equal to the square of the height plus the square of the base. That's what it means. If you put the square here at the height and the square at the base together is equal to this square alone. So that's what confirms that is the longest part. So that's the formula we have written. So you can do your own sketch, do your own normal drawing, draw it, the dimensions, and put it there, and it will work. Right? When you measure it with accuracy, do normal construction and do it, it will work. So the square here is equal to the square here plus the square here. That's what it means. If you want any of them, if you want to make any of them the subject, you change your subject, which we have learned. So if you are not watching your subject, watch it and see. But as you do examples, we apply it. Now, if I want hypotenuse, what do I do? It's not square root here and square root here. This cancel that. My hypotenuse is equal to square root of h squared plus b squared. Is that not the case? Simple. On the other hand, if I want any of them, maybe I want b. I want b. So it will be h squared minus what? Small letter a squared equal to b squared. But this one is crossing the border to the side, so it's minus. So at the end of the day, if I want b, here square root, here square root, this cancel that. B is equal to square root of hypotenuse square minus a square. So when the hypotenuse is known and you're looking for one other part, it's minus. It's the same formula, but it's minus. You subtract the smaller one from the hypotenuse. So the hypotenuse is always first. But if the hypotenuse is not known and that's what you're looking for, then it's addition, which we are demonstrated here. The reason why the square of the hypotenuse alone, that alone, is equal to the sum of the two squares. That's both height and base. That is so simple. That is the Pythagorean triple. So you can get number that satisfy Pythagorean triple, right? So here is what? If I have 5, 4, and 3, these numbers are Pythagorean triple. They satisfy it. Why? The hypotenuse square. So this one will be always the longest part is the hypotenuse square. So hypotenuse equal to 4 plus 3 squared. 5 squared is what? 25.